golden ratio is found by dividing a line into two parts. So you have line A and line B. And so when you divide these two numbers, you take the bigger number divided by the smaller number, and you get the actual 1.618. This should also be true when you take the longer number divided by the actual length of what it is. You will also get the 1.618.
Numerically, you can find the golden ratio either in the equation phi or through different number sequences, whether it's a ratio in the Fibonacci sequence, which actually finds the same golden ratio, or using the pre-cal equation of 2 times sine to the 54th degree, you can also find the same number. In about 300 BC, Luca Pacioli talked about the golden ratio and how it is able to apply in art and science. And as we had just talked about in natural sciences, it also appears in art whenever people are going for ratios, whether drawing people or for certain shapes, such as spirals, and in this case, a pentagram, for the scale of each part of the star to be 1.168 from the last measurement, from scaling to larger until you have the whole star. And another person who used this ratio was Leonardo da Vinci in many of his drawings and paintings, such as this one, my own rendition of The Last Supper, in 1509. Many of the different rectangular aspects on this painting, whether it was the balance of the apostles, and basically just how the whole rectangular shape of the painting had a lot of even ratios. And you could see this whether it was for measuring the center where Jesus is to the whole entire table, where it would involve even the spiral that's used a lot in the golden ratio. And starting from here, it would take up across the whole entire painting. And
So Phidias was a Greek sculptor and a mathematician that applied phi to the design of sculptures of the Parthenon. Anyways, according to this example or sample, the measurement A is corresponding to the lower measurement of the sample, which is B. So this is how A over B comes out, equaling to B over C, which B corresponding to C. And that also equals the width of the sample corresponding to the width of each column, between each column, which gives us N is representing the number of the columns that there is. So then that all equals to 1.6. And also if you do these separately, if you put A over B, it will always equal 1.618. And that is pretty cool. Also, another thing is about the human body. The human body is, can you see? This whole length right here is corresponding to the lower right here. And then, which also equals, I mean, doesn't equal, but it is also the same thing as B corresponding to C. And this guy, Phidias, or Phidias, it sounds like Phidias, he came up with the body being 13 over 8, equaling 1.625. It is almost at the ratio. And he also said that the female body is 8 over 5, which is weird. And it came out to 1.6. Okay, so according to my last example, it was about the architecture of the Parthenon. But now moving on to nature, the golden ratio is also found in nature. And if we look at this flower right here, the way that it's grown is pretty cool. The golden ratio is in between the petals, being 1.618, and the reason it's grown like that is so the sun can be exposed to it, because if otherwise, then it won't be able to grow right, I guess. But that's basically all for the flower. And now if we move on to this, the way that you find out if you're beautiful or not is by knowing if the width of your mouth is exactly 1.618 times the width of your nose. And that's kind of weird. It's really weird. But also, if they use this mask, the way that they know if like photography wise, like they Photoshop, they basically change your face into beauty, which is so wrong, but that's life. And according, you know, Angelina Jolie is so beautiful, and also they also use an example of Tom Cruise. So now, moving on to something really weird. This is the golden uterus, and the reason why we call it the golden uterus is because this guy, this OBGYN, he's very curious. His name was Jasper Burgess, and he used ultrasounds to take measurements of women's uteruses, and he came up with it being the actual golden ratio, 1.618. And also, if you compare, like, people basically are, like, what he's saying is that if your uterus is, if your uterus is basically the same measurements of Angelina Jolie's face, then you are very, very fertile and you can make babies and you're just very easy to impregnate. And